I'm gonna walk around a lot probably. I'll try not to though.
Okay, I mean, if you can just
stay right here.
Go over there.
The table if you want, but just if you can
Go over there.
I'll stay right here.
To the side of the projection stand. I just want to track you because the camera's too much. Okay, and then we'll start right here. Okay, you're live.
Okay. All right. Hey guys. Thanks for having us here today. I'm Saba Kazaruni, and this is my colleague Dan Sinclair. We work for a consulting company by the name of Security Compass. We do consulting and training, but we're very focused on application security. So in our daily job, we'll do the full pen test, threat model, source code review of client applications. So in order to help ourselves out, we came up with this series of tools called Exploitme, which help us test for cross-site scripting and SQL injection. And after a while, we realized these are really useful tools, so we'll release them out there for other people to use as well. I guess we can just move on. So just the agenda for this talk, we'll get into cross-site scripting. We'll talk about some advanced cross-site scripting, what's the worst that can happen. We'll show a couple of demos there. We'll talk about just web application security in general. What's the big deal? What's the trends? Why are these things so important to us? And of course, introduce the tools, cross-site scriptme and SQL injectme. They're both plugins for Firefox. And we'll let you know where you can get the tools. They're free. And what's next for the tools. Just out of curiosity, do we have? Are you guys mostly pen testers? Do you have any pen testers out there? Yeah, one. Coders? Yeah, a few. Okay, so you guys are probably want to use this stuff as well in the coding environment. Okay, so Dan, what's the big deal here?
Okay, so why do we really care about cross-site scripting? It's just an annoying pop-up box, right? What do you guys think is the worst thing I can do with cross-site scripting? Yeah? Get a cookie, yeah? That's pretty bad. Anyone else? Last year, there was a proof of concept release where someone could scan your internal network using JavaScript. So you can get cross-site scripted and have your internal network scanned, which is pretty bad from a network perspective, right? Anyone here think you can rob a bank using cross-site scripting?
I don't believe you.
He never believes me. Well, this isn't a real bank, because I'm not going to do that. This is my bank. It's basically equivalent to a real bank. It has simple features. So this is the International Bank of Dan Bank once we get there. It's a simple bank. It has, you can sign up as a user. You can register people to pay. You can put in the amount of money you want to pay, right? So it's just going to go along here, and it's going to show you some of the features you have, and then it's going to log into the bank. And what this is going to be using is it's going to be using a combination of CSRF attacks, so cross-site request forgery, cross-site scripting, and Ajax, once it actually gets to the robbing of the bank part. So the victim is signed into the bank, and he's adding a payee. In this case, he's going to add me. Everyone in my bank gets $1,000 because I'm a nice guy. He's going to pay me back $1 here just to show the basic functionality of what the bank site does. So so the bank site's pretty simple, and you can see it decrements current balance by $1. Big deal, whatever. So the thing we're kind of looking for on this site is there a cross-site scripting vulnerability? Because it's that cross-site scripting vulnerability which is going to allow us to steal the user's cookie, and once we have that cookie, we can basically do anything we want. The one caveat with this whole attack is that you have to know the person is on the bank site when you do this, but that's becoming a lot easier with something like Twitter. So we're just using tamper data. We're going to switch the username to be a simple script to see what happens when we cross-site script the bank, right? So we enters in the cross-site scripting attack, closes out tamper data, and you can see the pop-up box appears. So great, we got a cross-site scripting vulnerability, right? So when it tries to get a fake payee, it pops up this box. Okay, so this is what's going to allow us to actually steal the user's cookie, which will then allow the rest of the attack through Ajax to transfer money to an additional payee. So once it catches up, because he types slower than I talk. So yeah, it's a more advanced attack because it's using a multitude of Ajax plus cross-site scripting plus CSRF. So what he does is he just goes to a third-party website. So someone sends you a link through email or pops up on your Twitter and you click on the link, or you get it through Facebook, whatever, and you get this site, and it doesn't look like it's doing anything, right? It's just text. In fact, what this site is doing in the background, it's running a whole bunch of Ajax commands. It's connecting to the bank, steals the cookies through the cross-site scripting vulnerability, and then it adds a new payee and transfers money from your account to that payee's account. But as far as you can tell, it's not doing anything until you come back to your bank and you happen to look and say, oh, I just lost $500. So cross-site scripting, a lot of people don't realize it's actually dangerous. You talk to, whenever we find these kind of things in managers or in pen tests, the managers always say, big deal. I can get a pop-up box, who cares? This actually is a big deal. You can do a lot of stuff through JavaScript these days. It's becoming much more dangerous. So we'll get a bit of history on what's the current state of web app security from Saba here before we move on.
So web app security, it's nothing new, right? It's been around for a while. We've probably all heard of a lot of these attacks, cross-site scripting, SQL injection. What's interesting, though, is that it's not getting better. In fact, it's getting a lot worse. OWASP, which is the Open Web Application Security Project, they do statistics on these things, and they basically, based on their data, they are saying that about 70 or was it 80% of attacks on networks and applications are actually at the application layer. So a lot of this cross-site scripting, SQL injection is happening more and more often. Who here knows at least one website that has a cross-site scripting bug? Okay, a few. Okay. The rest of you don't, or you just don't want to put your hands up? But, okay. Well, if you don't know of any, there's a site out there by the name of XSS.com. What these guys are doing is they're holding basically a database of all the known cross-site scripting vulnerabilities on websites. So we do a search by top page rank, and you can tell right here, see how many Yahoo cross-site scripting vulnerabilities there are. And the X beside it means it hasn't been fixed yet. We have MSN on here, I believe, Google. Right? So it's out there. And in fact, something close to 75% of web apps out there are known to have a cross-site scripting vulnerability. Another 40% are said to have SQL injection vulnerabilities. And these are big numbers. Another interesting fact, if you've ever heard of the CVE, which is a Common Vulnerability and Exposures Database, this year for the first time, the number of web app attacks actually bypassed the number of buffer overflows, which used to be the majority of that list. Now we're having a lot of these types of attacks showing up more and more often. It's becoming a lot easier to exploit applications, and developers unfortunately don't either know about the attacks and don't know how to protect against them, or it's just a timeline thing and they don't have the right tools. So it's really in the hands of the developer to fix these things, and tools kind of become a problem. You need a tool that the developer can use very easily, and unfortunately it's not out there yet. So Dan, what is this cross-site scripting stuff? Maybe a little background would be good.
Yeah, so before we get into this, we sort of need to know what we're actually talking about and what we're defending against. So what is cross-site scripting? Cross-site scripting, if you consider a web page is HTML text, and in that web page you can embed JavaScript, right? And that JavaScript can manipulate the DOM, so the in-memory model of that web page. So you can use JavaScript to do pretty much anything. You can remove elements. You can add new elements into your HTML. You can request web pages. You can parse data that comes back. So it basically allows you to do all these functions in the browser. So this is a simple example where it's just requesting a URL and passing in the document cookie. So this would never actually show up on the user's browser. It would just run in the background. They would never know that it happened. An interesting vulnerability that came out last year was PDF files were cross-site scriptable. So any website that served a PDF file was vulnerable to cross-site scripting, because PDF files allow you to embed a tag on the end of your PDF name, which nominally is so you can set the page to move to, but they don't validate it. So you could put a JavaScript in that anchor on the end and have it execute cross-site scripting against any website. And this is on the client browser, so there's nothing the website's really doing. It's just Adobe's plugin was vulnerable to cross-site scripting. So suddenly, you see how this opens up access to your cookies on your website because someone links to your PDF, and they can suddenly steal your cookies. So there's two main flavors of cross-site scripting. There's reflected, which is what we're sort of looking at today. And reflected is what cross-site scripting currently helps with. So reflected, it's just popping something back up in your browser. It's not storing anything on the server. So you see a pop-up box or it runs something in the background. A stored cross-site scripting is when it gets saved to a database or a file or whatever, and it gets displayed to somebody else. So another user eventually navigates to the same page, and they get cross-site scripted. XSS does not currently handle stored. We want to add in the ability to do stored, but it has a whole extra layer of complexity because you then have to spider the entire site to try and find where the vulnerability might then be. So we want to put this in a future version. We just haven't got there yet. It's fairly complicated on actually doing it. So the other part of this is Ajax. At least for the IBD Bank example is Ajax. Ajax is asynchronous JavaScript and XML. So it's what allows the web pages to do those fancy things where pieces of the web page get replaced with something else. It's dynamic. It runs in the background. You don't have to do full page loads. So IBD Bank is using an Ajax script. The reason Ajax is kind of scary is that it can send data, it can receive data, it can parse data. So if you're using something like an anti-CSRF token, so a token to prevent cross-site request forgery, this defeats that because it can parse out that token and send it back to you. So all those anti-CSRF tokens are now useless because you can parse the data in Ajax. And our bank example would work over SSL because it's running from the client browser. You just can't tell it's happening.
So we're not saying here that there aren't any tools for pen testing. There are actually quite a few. There's open source tools. Anyone use WebScarab before? Yeah. Do you guys use any other tools?
Peros?
Peros, yeah, Peros.
Acunetics is really good, but it's a commercial one.
Okay, yeah, it's a commercial side.
Yeah.
Yes? Sorry? WebGoat? Okay.
Temperdata is a good one, yeah.
Yeah, that's a plugin for Firefox as well. So I think a lot of the open source tools, at least a lot of these tools are really proxies, right? They catch web traffic after you submit it from your browser before it gets to the website. When you have proxies like this, there's a little bit of complexity that gets added on. Now they have to pretend, or they have to do some of the functionality that the browser would do for you. For example, if you open an SSL connection, you have a proxy, it has to terminate the connection, it has to open up a new one, so it has to have the certificate management as well. They're not what we consider lightweight tools, right? So it's a lot harder, or you have to start up a tool aside from your regular testing that you're doing in Firefox. Anyone use commercial tools? You said you use one?
Yeah.
Pretty cheap, right?
Acunetics actually like automatically spiders everything and automatically starts scanning, so you don't actually need to know anything.
Yeah, so you just click a button saying go.
In order to use it as a scanner, you just need to get through the login sequence and then hit go.
Yeah.
Cool.
It's kind of, and Peros actually works the same way. The only problem with Peros is that it hasn't been updated in 2 years.
Mm-hmm.
But otherwise it would be fine, and it also doesn't do the auto spider.
Yeah, Peros does have a scanning, you're right, as well, but it's not the best. I know I've tried using it as well.
It's alright. I mean, it's not as good as Acunetics is.
Yeah. Have you tried WebInspect?
Yeah.
Yeah, WebInspect is pretty good too. I mean, they all kind of do the same thing. They'll crawl the website and they'll fuzz various fields and they'll try to do the various tests. Again, a lot of these, they're either very expensive. Commercial tools can go for anywhere between 20 to 50,000, right, for an enterprise license. Sometimes they're sold per seat or per run, but again, it's a cost factor. Another part of the big problem is that we want to have everybody in the software lifecycle, developers, QA, and pen testers at the end to be able to use these tools. Developers, they understand the app, they understand web traffic, they can use a tool like Peros or a tool like WebScarab. QA sometimes, they just want to test it, right? They want to test the functional requirement, see if the data going through is fine, the output is exactly what they expected. With something like WebScarab, all of a sudden you have this breaking down of your HTTP request, and it's good for what it does, but in some ways it's a little too complex for somebody who may not have that development background. And what we're finding is, and we work with a lot of developers and QA personnel, we do training. What we're finding is that they're not using a lot of these tools because it requires them to start something up aside from their browser. A lot of times they're very heavyweight, so it's taking up a lot of resources, and they get frustrated, and they just rather not use it. And that's aside from the fact that requirements usually don't have security in them, right? So we just assume the developer is going to do it. So let's make it easy for them. So the best approach, as I already mentioned, is really to do this in various phases, right? So we need a tool that developers can use in code during the development environment. The QA can use it in the test environment, and if you're pen testing or you're doing testing post-production, you want to use the same tool there as well. So Dan, is there any hope?
Yeah. So that's why we made Cross-Site Script.me and SQL Inject.me. Cross-Site Script.me and SQL Inject.me, they're Firefox plugins. So we figure instead of doing this through a proxy, why not build it into Firefox, which is going to be smart enough to do all this stuff anyways, right? So we have Cross-Site Script.me. So Altamiro, it's a test site for a vulnerability scanner, I think. I think it's from Watchfire. So it's not actually a live site I'm doing this against. But what you can see when you run Cross-Site Script.me is it comes up here and it tells you, these are the forms that are on my page. So this page has one form called form search. That form has two fields. So I can select these fields and say, okay, I want to run these cross-site scripting attacks against it, or I can run it against this one, or I can do it against all its forms with all attacks. So you can have multiple forms on your page. And we can run this thing, and it always pops up on the wrong thing. And it goes off, and it does some heuristic testing to decide what it wants to do, and then it starts running attacks. You can see it's popping up a whole lot of tabs at the top. What it does is it runs multiple tabs in the background, so each tab will submit a request. And that request will have your cross-site scripted value in one of the form fields. So it'll actually run a whole lot of attacks because it puts the correct values into each form field, except for the one it's cross-site scripting. Because what we've seen is that you'll often have cross-site scripting vulnerabilities that will only appear if all the other fields are correct. So cross-site scripting is trying to check for that. And you can see when we run, we've got these red boxes here, which Sabo will describe heuristic testing to you in a minute. But it's basically telling us that this field will allow us to enter a semicolon. It will allow us to enter a slash. So we just check ahead of time. This field isn't vulnerable to any of these characters, so there's no point in trying to cross-site script it because none of our cross-site scripting tags will get through because they all involve one of those fields. And we can see that on this page we had one failure, 3 warnings. So the failure, we can see that it let us put through script document vulnerable equals true. So we could go back to that field and put in something like script alert XSS.me, and it would pop. Yep.
Do you do the same fields with encoding? Or do you just
We do not currently do encoding. We want to do encoding in the future. We don't do it yet. Yep.
I have another question. What it does so it does checks for single characters before, and then based on those, it decides how to do certain tests.
Yeah.
So my question is, in many sites I've seen, from get parameters or post parameters, the results of that will appear on many different spots in the source HTML and can be encoded or sanitized in various different ways depending on where they appear. It shows up in a hidden tag, maybe it's injectable. It shows up in an XML attribute, maybe it's injectable, maybe not, one way or the other, right? So how do you look for a single character in a known location?
I believe I didn't write that chunk of code, but I believe what he does is he puts like a guard on it. So it'll be security compass, semicolon, security compass. Gotcha. And then if it sees that semicolon in between the words security compass, it now knows, okay, that's my semicolon. Yeah. So it doesn't have to pick one semicolon on the whole page. It puts a guard around it so it can then tell.
So and is it sensitive to multiple
yes.
locations?
I believe so, yeah. So the other thing you'll notice is we have failures and warnings. And the reason we have warnings is just because it does a double request. And we'll explain the double request to you because there's some scripts that won't execute but will still be on the page. So we have to double everything, and we'll explain that to you in a minute. So what are some of the features of cross-site script.me? So, well, features. I'll talk about the options actually. Tools. So we open this up, and you can see we have what's called the preferred number of attacks to test. So the thing with this is if you have a lot of attacks, it can take a long time to run them all, just because it has to do so many requests to your web server. So often you'll want to say, okay, I have these 9 attacks that my website's been vulnerable to before, so I always want to run these 9. So you can say, I want to run the top 9 attacks, and we'll just do those 9. So it just speeds it up a little bit, so you don't always have to run all of them. The other thing we can do is we can say, how many tabs do I want to run with? The more memory you got, the more tabs you can use. The more tabs you open up, the more memory it's going to eat. So if you want to use all your memory, open up a lot of tabs. It'll just keep using as much memory as it wants. That's a bit better in this new version. I'm actually showing you the unreleased version that's being released next week or the week after or something. So it actually does better memory management than the old one did. There was some leaks that we fixed. The other options you can see, we're using heuristic testing. So if you don't want to do that heuristic stuff, you can just turn it off, and it will always run against all the fields. And you can see we can enter special characters that we want to do heuristic testing for. The reason we let you change the heuristic testing characters is because you can change the cross-site scripting strings. So by default, what it's shipping with is the list of strings that RSnake publishes. So RSnake he's a dude, and he has like the definitive list of cross-site scripting strings. So they're all in here, except for any ones that reference a third-party website, because we didn't want people to think that we were trying to track their usage of this by redirecting them to our website to pull a script down. So what we've done is, on our website, you can download those extra strings, and you can grab the cross-site scripting JavaScript file and put it on your own website. So it points to your web server, so we don't know you're running it. But you can add, remove these. You can export them, import them, move them up and down the list, depending on how you want them to show up. So basically, we want you to be able to add any extra attacks that you think you want for your website that we might not have thought about. And I was just going to show, so I'm going to show a video here of the old version, but what it's showing is that it executes against all fields. So there's a program called AppFuse, which is an open source tool that I think it's to make websites or something, but it has a cross-site scripting vulnerability in one of its hidden fields. So XSS runs against everything. If it's hidden or if it's not hidden, it will run against all of them. So we open up the test form here. It opens up cross-site scriptme, and we're going to run against a very specific field, which is the ID field in this case. So it takes the ID field, and I believe it runs, the top 9 attacks. And this one looks different when it runs because this is the old version. So if you downloaded it right now, this is what you would see. It's not as nice feedback and stuff, but I think it's beta. So these things get better over time. But we can see AppFuse has 3 failures on that one field for cross-site scripting. So we can see that there's 3 ways to get in through that hidden field. So the thing we've noticed when we do these things is a lot of developers don't necessarily realize how easy it is to change hidden fields, for users to come in and just submit these things.
Yes.
So 3 fails, is that 3 signature fails on one field, or?
Yes.
Yeah, I think. Yeah, in
Three
this case, we were.
Is there any way to tell easily by looking at the interface how many fields failed?
Yes.
I believe the new version actually orders it by field. It'll say this field, we tested this, this, and this. These are the fails.
So what you're seeing here is it ran against text search field. So the text search field specifically, it submitted to the other field go, because there's 2 fields on this page. One is the text field, and the other is the go button. So on the text search field, it submitted this to the other button, and this was the failures against that field. If there was failures on another one, you'd see another blue header with the name of that field and everything listed below it. So it separates out all the fields specifically. So in the video demonstration, it was that one field had 3 failures.
Yeah, and we'll talk about what brings up a warning in a bit. So there's different criteria for a fail, warning, and pass.
So I talked about heuristic testing, and now Seb is going to actually explain.
Sure, I think you already pretty much covered it, but we realized that again, so the version that you download now does not have heuristic testing. So we realized that you could have up to 100 cross-site scripting strings, and you have 10 form fields, and if you just run it against your entire form, that's 1,000 tabs, right? So it's sometimes very, very slow. So we thought, okay, if a certain field can withstand all these characters, which we believe are the characters that are included in most cross-site scripting strings, then we'll just skip that field altogether. And it turns out that most forms, there's only 1 or 2 fields that have this property. So it makes it a lot faster, and again, it's in the next version. And it's being released in RSA, FYI, which is next week, I believe. So this slide is kind of explaining how cross-site scripting works behind the scenes. When you first do a test for cross-site scripting, you put in a script and you see the result, and usually that's an alert box, and that's kind of everything's good to go. We needed a way to obviously do that programmatically. So what we do is we create a document.vulnerable DOM object and DOM variable. And before cross-site scripting runs, we set that to false. And if you notice, most of our, can you pull up the attack strings, please? If you notice, most of the attack strings, all they are is different variations of a script that says document.vulnerable equals true, right? So, we know that if the script executes afterwards, document.vulnerable should be true, and that's how we're really testing if this is working. There were a few cases where, you can leave it here, that's fine. There were a few cases where the script wouldn't execute. There are certain type of cross-site scripting vulnerabilities that the script is on the page, but it won't execute until there's a certain user action, such as on mouse over. If you can inject an on mouse over event, only when the user hovers their mouse over that field will it execute. So, in order to make sure we're catching those as well, what we did was now we're sending 2 requests. So the first request that goes across, it checks the rendered version. It says, is document.vulnerable equal to true? If that is true, that's where we see a red flag. So all the failures that you saw means the script actually executed. So what we do next is send a second request, and this time we're not looking at the rendered version, we're just looking at the HTML that came back. Is the script in its exact same format that we sent it out, meaning it wasn't encoded. If that's the case, we're getting a warning. That's where the yellow flag comes up. And there's a couple of cases where within Firefox, for example, the script doesn't execute, but in IE, certain versions of IE and Netscape it does. So I think one of them was within IE 6, I believe, and below, was it Dan?
I think it's 6.7 in Netscape.
Okay. IE 6.7 and Netscape, they actually allow you to define your own tags. So a form or tags such as the one Dan is about to pull up, I'm not sure if you guys can see that, but all it is we've created a tag by the name of XSS. Within Firefox, this tag doesn't get processed, but in certain versions of IE it does, and it allows us to actually input JavaScript just through that tag. So for these cases and cases where we weren't sure, okay, maybe it's just a Firefox thing, we just look to see, did the script come back? If it did come back, maybe you're vulnerable in other versions. So we give you a yellow flag. Everything else is a green. I mean, if neither of the 2 pass, then...
So thankfully for this, we've got struts, right? Everyone always tells me, if you want to be safe, use struts. Struts is safe from cross-site scripting. Sure, using a framework is actually a really good idea. Just don't actually follow the struts examples, because the example struts ships with are, I think that just crashed. No, maybe not. Hello? Let's try that again. Okay, I might not be able to show you this. The example struts ships with, there's a file upload example. So in that file upload, I think you can set the name of the file. That field is actually cross-site scriptable by default. So the struts examples are cross-site scriptable. So the problem with this is that our developers are taking these examples and they're using them in their websites because it's the struts example, but it's vulnerable to cross-site scripting. So you can see how this sort of gets propagated and becomes a really big issue, right? So that's cross-site scripting in a nutshell. The other tool we have is for SQL injection. So Sab is going to explain what SQL injection actually is.
Any questions, first of all, before we go on?
If my slide presentation. Okay, there we go.
Does anyone here, is anyone not familiar with SQL injection? Maybe a little more detail you'd like me to get into? Okay, so I'm sure we've all heard of it. Just a quick example, and this is the basic example of bypassing authentication. Whenever we have dynamic SQL, we're including username and password or any type of user input without validating it. It allows the user to modify that SQL, right? So in this case, the user has actually inserted a or 1 equals 1 into the SQL. This query will return every row in the table, right? So we can bypass authentication. So for, the defense is pretty simple. I'm not going to get into details, but using prepared statements and stored procedures is the recommended approach. I think more importantly is how we can test for it, right? How can we test for SQL injection? I think Dan's going to do a demo of SQL Exploitme, which is the other side of Exploitme.
I don't know because my videos are all crashing now, but I will show it in a second. See if this works. Aren't you glad you use Vista? Oh, my task manager doesn't work either. That's nice. So that's pretty toast. Oh, there it goes.
And we're not even doing live demos, and it's still screwed.
Yeah, I can't even show videos correctly. Imagine if I tried to do these things live. Microsoft. What do they call the media player? Media player. And, okay, I don't think that's going to work. There's an open source CRM program called Daffodil. Daffodil, by default, ships with that exact SQL injection issue on its login page. And they're telling people use Daffodil as your CRM software. They've known about this vulnerability for over a year now, and they don't care. They don't bother to fix it. They don't think it's an issue. Can you imagine if your website or your company is running their CRM software and someone breaks in through this quite simple SQL injection, which most people can find out just by inserting a tick into the web page? So for that kind of thing, we have SQL Exploitme, which looks very similar to cross-site scriptme in that it opens up and it looks pretty much exactly the same. I'm just going to go to this page. You can see this page actually has two forms. So it has the search form and the login form. So we could run this against either form, depending on what we want to search, or we could run it against all forms. It's just depending on what we want to do. So we can take this and we can execute our attacks against. I should actually pick a field. And it will go off and it will run SQL. I'm using the beta, as you can tell, and he obviously forgot to change the XSS to SQL inject. So ignore that for now. And it will go off and run and find certain errors. The thing with SQL Exploitme that's a little bit different from cross-site scriptme, when we come and look at the options here, we don't know what a failure is for SQL injection. The problem is that an SQL injection failure could actually be the correct functioning of your website. So the way we get around that is the one thing that we look for by default is database error. So if you get an error back, we know there's something wrong, right? You're vulnerable to something. The other thing we let you do is you can come in and put your own result strings in here. So if you're testing your login page, you can pick out a string in your login page and say, okay, if this appears, I'm vulnerable. So you have to customize this to your app. It's not quite as nice as cross-site scriptme in that it just does it. You have to do a little work on your app and say, okay, this is a failure condition. The new beta version of this, I think, has like 6,000 database error strings in it or something so that it can try and pick all these things out for you. But there's a little bit more work you have to do to define what exactly is an error. So similar to cross-site scriptme, though, you can export, import, move these things up and down the list, add, delete. And the same with the general, how many tabs do you want to run against? There's no heuristic testing for SQL injection, although I guess we could probably try and put something in. We don't do any of that at the moment. We just do that for cross-site scriptme. So that's SQL Exploitme. So if you're curious where you can get these from, they're downloadable from our website. And before you take these and put them in Firefox 3 and email us and say it's broken, we know. We haven't bothered to update support for Firefox 3 because Firefox 3 changes a whole lot of APIs and we have to go back and change a whole lot of stuff. So we're going to do Firefox 3 support probably just after it's released. Right now it doesn't work. So we know it doesn't work. Don't bother to email us and say this doesn't work because we get that enough. They're all open source, GPL version 3. So we want you guys to take them. We want people to use them because we want people to fix their applications. You know, we're pen testers, but I don't like to see all these cross-site scriptable web pages because these things are easy to fix. The problem is developers don't know how to test for it. They don't necessarily know how to check for it, and they don't bother, and it just keeps propagating. So, and in terms of future tools, so as Saba said, SQL Inject.me and Cross-Site Script.me 3 are going to probably release next week at RSA. Eventually, we're going to add the auto-encoding, which somebody brought up. We also want to add stored cross-site scripting. Those are both, they're kind of nasty to do because just the scope is huge. But we're also going to do a few other tools like forget-me-not. So using forgot password fields to try and do user enumeration. And then something like brute force me. So a simple Firefox plugin to try and brute force people's passwords once you know what they are. So we have a few tools sort of in this Exploitme range that we want to create as Firefox plugins to help people pen test their apps during development.
Yeah, just a couple of things to add. There's URL parameters and cookie parameters. It's currently not supported either. That's they're obviously cross-site scriptable as well and SQL injectable. So in the future versions, we're also going to work on that as well.
So there's a few things on the table we want to add on to these. It just takes time. We want to get at least the basic functionality of this out into people's hands so that they can start using it. So, any questions?
Yes. Oh, it's xssed.com. XSS.com. Anyone else? All good? Okay, thanks guys. Appreciate it. The PowerPoint? We can probably message you in PDF. That shouldn't be a problem. Yeah,
Okay.
no problem.
Sends me by PDF? Okay, so...
Do you want to give me a...
You have a USB key or something?
Yeah, well, you said by PDF, so you have it.
You know what? Here, let me give you...
Just give me your email address and I'll email
yeah.
it to you. That's the easiest way.
Nice tools, man.
Thanks.
I took a look at them today.
Oh, you did? You used them?
Yeah.